Now I think a good exercise would be to work through the example of calculating inflation that is in the textbook. I'm looking at table 7-1, which is on page 150 in Miller. I'm going to work through this thing and explain it as I go. I actually think, at least in the box itself, it kind of leaves you hanging. It doesn't really tell you quite what the outcome of what you've done there means, and I'll make sure I fill in that gap. So, I'm going to basically, I think I can do this. I'm going to recopy this table so this time we can see right where these numbers are coming from. I'm going to try to fit everything in between here and there. So we're looking at two goods that the typical consumer might purchase. We're proceeding as if these are the only two goods that a typical consumer might purchase if we're calculating CPI. It's a basket of goods that the typical consumer is believed to purchase. And so we're talking about corn and devices. You know, our phones, our pads, our pods, our books, our laptops, all of those things. In the first year, it's decided that the typical consumer purchases the basket quantity of 100 bushels or 100 units of corn and 2 devices. So 2 units of devices. I'm just going to call them units rather than put qualifiers on those as to what the units are. And the textbook starts with 2009. Let's just call that year 1. Okay, the first year we're looking at. So the year 1 price is $4 for corn and $450 for a device. So that's per unit cost. So that means year 1 basket, I am going to run out of space here. I'll work with it. Is, well, if you buy 100 units at 4 each, that's $400. And if you buy 2 units at $450 each, that's $900. Okay? So that's what the typical consumer was spending on these goods, the basket of goods the typical consumer buys, back in year 1. But then some time passes. The author gives us 10 years. A lot of times this is just year 1, year 2. So at later years, we go back and we look at corn and devices, and we see, I'm going to have to start down here in a new section. The typical consumer is going to still buy the same basket. This is something that trips people up sometimes with this and sometimes with other things that we do that are like this in later chapters. They want to go with a new basket just because sometimes that's provided in the table. Remember, it's the same basket of goods. So the same basket carries over or carries down. That's 100 units and 2 units. Because that's what the typical consumer buys, is that much of the good. That's the idea here. But prices change over time. So in year 2, prices become $8 for the corn. So you'd see that and say, wow, prices double. But that's only part of what the typical consumer buys. The typical consumer also buys devices. And over time, devices have actually come down in price. That could be because of competition, technological advancement, and things like that. And so these are now $3.50. So we can't just point to the negative and say, oh, inflation, prices are doubling. That's not really an assessment of what inflation is. And we certainly can't say things are getting cheaper because the devices are getting cheaper, because that's only part of what the consumer buys. So we're balancing these effects, right, by calculating this. So then we need to know what the year 2, and this time it's 10 years later, basket is, the second year we're looking at. And so now if we go back to the same basket that it was that the typical consumer buys in the terms of the quantities. That's 100 units at $8. That's $800 spent on corn and $700 spent on devices. Okay, so now to calculate a price index, the formula, if you want to call it like that, goes something like this. A price index, typically in the US, we're talking about CPI, is equal to something times 100. I'll fill in those blanks. It's the current value, or the year two, the second time period you're looking at, of the basket. The same basket over the base year value of the same basket. So what that says is the current value of the basket over the base year value of the same basket. This example is not too tricky because they only give us the same quantities. I mean, they only give us the quantities one time. Sometimes they tell us different quantities with some other exercises. And so I'm just trying to help you watch out for that landmine. You use the same basket as you did in the base year, but in current or nominal values on the top. And so that means we want to figure out what these baskets are. What's the price of the basket in the base year, and what's the price of the basket at the end? So let's see. This is the basket here. I don't have space to write it there, but that's $1,300. Right? That's 400 plus 900. And then the same basket in the second year became $1,500. So now if I use my formula here, we're talking about 1,500 over 1,300, and this is times 100 just to move the decimal over. That's what multiplying something by 100 does. And so what that equals is 115.38. And you say, oh, fantastic, I've calculated the price index for the second period. That's great. Does that make you feel fulfilled? I don't think so. Because, as I said at the beginning, this thing doesn't really tell us, like, it's a calculation with no meaning, with no context in just table 7-1. So let me point out a couple things. Base year is year one in the example. So base year, usually when you're given these kind of exercises, is the first year that you're looking at. Sometimes the first year you're looking at isn't the base year. Sometimes they would say, okay, so here was base year, here was the second year, here was the third year. What was inflation from the base year to this year? What was inflation from this year to the next year? And that really complicates things. But there are a lot of questions that could come your way that are like that. And by the way, the real world is more like that. So base year happens to be, in this example, the first year we're looking at. And so the price index value for the base year is always 100. But they don't always use the base year. Okay, so here we're going to use 100 as the base year index value of 100. The reason why that is so is because in the base year, if you think about this, the current value is the same as the base year value, and anything divided by itself is 1. So 1 times 100 is 100. So that's why the base year is always 100. And why am I making such a big deal out of that? It's not in the text box or in the table 7-1. So why am I emphasizing so much that we need to look at this 100 versus 115 thing? We already calculated it, didn't we? Why are you talking about more? Because this doesn't mean anything by itself. It's just a number. It's kind of senseless. When you get CPI data, if you're watching CNBC and CPI is released, Steve Leisman, the economics reporter for CNBC, doesn't come out and say, oh, the price index is 115.38. That's not the news. That's useless. It's just a number. What's useful is how it's changed over the time period. So we need the percent change because inflation, when we look at it, is expressed in rates, the inflation rate. So when you calculate the rate, let me let you in on a little secret. The rate of anything, you can find far more sophisticated formulas to describe the rate of change of things than what I'm about to write here. But I'm telling you, what I'm about to write here is just an easy, rhythmic kind of formula that you can remember and apply for this and a lot of other things in life. Percent change is calculated as new minus old over old. So this example is too easy for me to really emphasize why I'm expressing this. So let me go ahead and explain a little bit more. I was taking an exam in my, I believe it was a college algebra class, early days of my undergraduate experience. I was taking an exam, or I was preparing for an exam, and then I took it. And in preparing for it, I knew percent change was going to be something on the exam. But I thought to myself, well, if something goes from $100 to $115.38, I know that's a 15.38% change. That's easy. I don't need to study this part. So I skipped it in my preparing for the exam. Then the exam came. And the numbers weren't 100 and 115.38. They were more like 115.38 and 126.53. What was the percent change? And then I looked at that and I said, oh dear. And so I'm going to try to spare you that agony. I was tenacious, and I saved it for last. And then I came back to it, and I said to myself, well, if I know something goes from 100 to 115.38, and that amounts to a 15.38% change, what is it that I'm doing to get to 15.38%? And that is what I'm doing, which if you look it up, that is the formula for percent change. It just says things like the percent change in quantity is Q sub 2 minus Q sub 1 over Q sub 1. That's still new minus old over old. So what I'm saying is new minus old over old is this little rhythmic tool that you can use and you can apply anytime you're asked to calculate percent change in economics class or in chemistry class or in biology class or when you're shopping. It's a handy little thing to have. So let's go ahead and use this just to confirm the truth in what I'm saying, which we probably can already see with this number. So if I want this percent change, 115.38 minus the base year index is and was and always will be 100 over 100. So you have 1538 divided by 100, and you have 0.1538. And then if you convert that by moving that decimal over, you're talking about 15.38%. That's the percent change if you've gone from 100 to 115.38. And that is the inflation rate in this example, the 10-year period that we're looking at. And so from that, you could walk away and say, on average, over this 10 years, inflation has been 1.5% per year over this 10-year period because the general rise in the level of prices has been 15.38%. That's what that example is about. That's how you do these calculations. And I hope this is something that you can use.